4.3 to talk about multiplying and dividing fractions. We first just kind of have to look at these fractions and look at how to simplify them. Okay? Okay. Quick vocab. A rational expression. We talked about a rational expression last week. Rational expression is one that is a fraction. Just like if a number is rational, then this rational expression is a fraction. As you look all throughout your notes, you see these fractions. Okay? So the first thing we're going to work on is how to simplify them, and then we'll work on multiplying and then dividing. Now, we are going to have to talk about domain just a little bit. There's going to be a set way we do it, so it'll be easy to figure out. But the domain, we talked last week when we looked at the graphs. It was all real numbers except where that vertical asymptote was, right? So except some x value. It's still going to be the same thing. The domain is going to be all real numbers except for where the denominator is equal to 0. And those are what we call, this book uses the phrase restrictions on the variable. I've taught out of books before that use the words excluded values. Okay. So, but we will talk about that. And then you'll also hear me as we talk about what we can and can't simplify. You'll hear me talk about terms being married. Okay? Because as we look at these, as you guys start looking at A, for example, a common mistake would be like, oh, hey, let's cancel x squared and x squared. That's a huge no-no. Okay? That's not how we cancel here. Okay? And so that has to do with expressions with plus or minus signs are considered married. Okay? Meaning you can't split them up. Okay? So terms cannot be canceled. X squared, those are terms that I pretended to cancel there. Okay, and then I backed that up. So factors have to be canceled. So key thing we're going to be looking for, a lot of, are factors. So, how's your factoring rules feeling? You know how, remember how to factor? Okay, so let's look at A. They ask us just to simplify this expression, and then we're going to state any restrictions on the variable. So we'll worry about that here in a moment. Let's worry about just simplifying the expression. Okay, I already discussed. Can you cancel x squared and x squared? No, that's not an option. They are terms that are added and subtracted to other terms, so we can't do that. We've got to talk factoring. Okay, a lot of the factoring is going to be basic. I'll help you through it, though. We've got to review these factoring skills. So, what do you remember about x squared minus 4?
It's just two parentheses like x plus 2, x minus 2.
Mm-hmm. Does that sound familiar to you guys? It should, I hope. Okay, x squared minus 4. If you want my vocabulary, I'm going to call it the difference of squares. Not that you necessarily have to know that to survive, but I'm going to call it the difference of squares. X squared, we've done a lot of this. Breaks into two x's, x times x. 4, what's the square root of 4?
2.
It's 2. And then in order to multiply to get a minus 4, you need a plus 2 and a minus 2. Okay? I need you guys to become comfortable with that factoring. Now, what about the denominator? We should be a little bit more comfortable with the denominator, I think. X squared plus 3x minus 10.
Let's go 2 x's and 5 and 2.
Okay. X squared, again, breaks into two x's, x times x. Numbers that multiply to be 10, negative 10, I guess, and add to be 3. Is some combination of 2 and 5. If it multiplies to be negative 10, one of those is negative. How do we get that to work when we need it to add to be positive 3? Negative 2, positive 5, because 5 plus negative 2 is 3, yes? Or negative 2 plus 5 is 3. Okay, guys, what did that accomplish for us? What do you see?
The x minus 2 and x minus 2.
Okay, these are factors, folks. You can cancel a factor. Okay, these are factors because they're multiplied. So you can cancel an x minus 2 on top with an x minus 2 on bottom. Okay, Your canceling there is done. Rewrite your answer. So now I'm going to have the answer of x plus 2. Yep. Over x plus 5.
That's the answer.
That's the answer. Okay. Now I'm going to tell you, in these beginning stages, you're going to be tempted to say, oh, now let's cancel the x's, yes? But we can't do that. Okay? That x is added to 2. The other x is added to 5. You can't cancel terms that are added and subtracted. It has to be the whole factor. Now, if we had x plus 5 on bottom and on top, we could still cancel more factors, but we don't. Okay, that's your simplifying the expression. Now, there's another piece we're asked to do here, and that is to state any restrictions on the variable. Okay? Restrictions are anything that would make the denominator 0. So this is where we go back and talk to about domain. It's anything that would make your denominator equal to 0. So take a guess. If we're trying to figure out what values make our denominator equal to 0, what could we do with that denominator?
Set it equal to 0.
Set it equal to 0. Okay, so in order to find our restrictions, I'm going to say take your denominator and set it equal to 0. Now, which version of the denominator do we want to set equal to 0? I'm going to tell you, you don't want to go just for the final answer because we canceled some stuff out, didn't we?
So the first version?
Well, okay, so your options are, you could go with the x squared plus 3x minus 10, the original. But then if I set that equal to 0, what am I going to have to turn around and do? I'm going to end up having to turn around and factor it. So my suggestion is always go with the factored version before you canceled anything out. So you're setting each factor equal to 0. What factors did I have before I canceled anything out? I had x minus 2 and then x plus 5. Anything that was ever in the denominator, we're going to set equal to 0. So I'm going to set, what do we say? X minus 2 equal to 0. And x plus 5 equal to 0. Sorry, I was trying to decide what I wanted to do here. Okay, so we're going to set both of those equal to 0. Basic solving here, folks. If it's x minus 2 equals 0, what do you know? Add the 2 to both sides, right? And so we're going to get x equals 2. And if it's x plus 5, what do you know? Subtract 5, and we're going to get x equals negative 5. Now, here's the deal. Can x equal those values? No, because that's where we set our denominator equals 0. So what we're going to actually say is that x cannot equal 2, and x cannot equal negative 5. And actually in homework, they'd have you express that as like negative 5 comma 2. You just do it as a list of numbers. So those are my restrictions on the variable. Those are my values that will not work in my denominator. Okay, they will not work in my denominator. Okay.
Those are both the same answers.
Yes, so you would be asked to simplify the expression. So I have a fraction answer here. And then when you're asked for restrictions on the variable, it's going to be a list of numbers. My numbers here are going to be 2 and negative 5. And I get those from saying the denominator equal to 0. Okay. Questions I can answer at this point? Shall we try the next one? Okay. B. X squared plus 2x plus 1 over x cubed minus 2x squared minus 3x. Thoughts about simplifying this?
From the bottom, you could take an x.
Okay. Is there a GCF in the bottom? Is that what he's saying? All three terms have an x in common. And that's going to be really helpful. So if I factor out that x in the denominator, x cubed divided by x becomes what?
X squared.
X squared minus 2x squared, if I divide an x out, becomes 2x minus 3x, if you divide an x out, becomes minus 3. Now, am I going to be done with that denominator? No, it's actually going to be able to keep going here in a moment. Okay. You want me to just copy down the numerator and we'll factor it in the next step then? Or you want to go ahead and factor that numerator? What about x squared plus 2x plus 1? Does it have a GCF?
No.
No, there's nothing that all the terms have in common other than 1. 1's always an option, but doesn't change anything. How do you think this is going to factor?
Like x plus 1. Both plus 1s.
Okay. Should factor into 2 parentheses, yes? X squared breaks into x times x. Folks, there's only one option to get 1. How do you multiply to get 1 in this scenario? 1 and 1. And coincidence, what is 1 plus 1?
2.
2. So you need plus 1 plus 1. Now, you know we're not done yet, right? We need to factor finish factoring the denominator. So I'm going to rewrite this. My numerator, I already have x plus 1 times x plus 1. My denominator, what about that x out front? I'm going to carry it down, right? Don't lose it. Don't forget about it. And then what about x squared minus 2x minus 3? If we had to guess, it's probably going to factor into 2 parentheses. Okay, I'm not saying it always will, but that's the logical guess, right? That's the logical place to go to. X squared breaks into x and x. I need numbers that multiply to be what?
3.
3. What multiplies to be 3? Only one option.
1 and 3.
1 and 3. Okay, make your signs happen. If it multiplies to be negative 3, you need a positive and a negative, yes? If we need those numbers to add to be negative 2. Yeah. We need the larger number negative, so positive 1, negative 3. You see anything here?
Put 1 and x. I mean, can you cancel? Is it just 1 or can you cancel?
How many x plus 1s are on bottom?
Just 1.
So how many can I cancel on top? 1. 1x plus 1 on bottom means I can cancel 1x plus 1 on top. It's a 1-to-1 ratio here. Okay? So what remains for my answer then? On top there is still an x plus 1. In my denominator there's x minus 3 and
X.
don't forget the x. So x times x minus 3. Good news? Leave it in factored form, folks. Don't multiply it back together. Waste of time. Leave it in that nice factored form. Okay? Now, we can't move on to this problem yet because we have to find the restrictions. What's going to cause a denominator problem? Okay, remind me, how do I find my restrictions? Okay, restrictions. We're going to set our denominator equal to 0. Now, denominator equal to 0. And? Okay. I wouldn't use my original form. before it was factored, because you're just going to have to factor it. Your factored form before you canceled things out, which was that right there, yes? So there's the x minus 3. There's the x plus 1 I canceled. There's also the x. Does it matter? X does matter this time because x is a variable. If it was just a GCF of a number, you could forget it. But because it's a letter, it matters. So I'm going to set x equal to 0, x plus 1 equal to 0, and x minus 3 equal to 0. Okay? Well, my first restriction is going to be x cannot equal what? 0. If we set x plus 1 equal to 0, what do we know? Can't equal negative 1. And if I set x minus 3 equal to 0, what do we know? Add the 3 over, it can't equal 3. So in homework, on a quiz, on a test, I'm just looking for a list of numbers there. You don't have to write them as separate pieces. But x cannot equal 0, negative 1, and 3 in whatever order you list those. And here's the deal, guys. If I put any of those numbers back in here, it makes my denominator 0, and that makes that fraction not exist. Okay, we can't have 0 on the bottom. Okay, you catching on?
Yeah.
Okay. C.
This can be like where you split the problem into 2 or something like that.
On the top piece?
Yeah.
Okay, so first of all, I would take a moment. Are there any GCFs?
No.
Does my numerator, my top, have anything in common across all 4 terms? No. Does my bottom?
No.
No. Now, I'm going to say it because I know some of you are thinking of it. Some of you probably just want to say, ooh, cancel the 4s. But we can't do that, right? Those minus 4s are married to the other terms. You can only cancel factors. So we are going to factor. Let's start with the denominator. And then I'll come back and grab the numerator here in a moment. Just because my denominator will be one step and done. X squared plus 3x minus 4.
It's going to be 2x's.
Okay, are we kind of, I feel like saying same old, right?
Yeah.
X squared tends to break into 2 x's, x times x.
4 and negative 1.
Are you guys, in order to multiply to get negative 4 and add to be 3, it's going to be a combo of 4 and 1. Adding to be positive 3 makes it bigger number positive, so positive 4 minus 1. Multiply those back together, or add them back together if you're not sure. Now, the numerator is a little trickier, isn't it? Because there are 4 terms. Okay? 4 terms. Officially, it's factored by grouping. We don't see this one as much, but it's a good one to know. It really is. It pops up, and it's good to know. Factor by grouping means I split this top piece into 2 halves, right? Sound familiar? And then, what is the GCF of the first 2 terms? So what do my first 2 terms have in common?
X squared.
X squared. So we're going to put the x squared out front. If you have x to the third and you divide out x squared, we're left with x. 4x squared, divide out the x squared, you're left with plus 4. Repeat on the second half. What do minus x and minus 4 have in common?
Negative 1.
They're both negative, yes? And anytime the first term is negative, I'm going to say factor out negative. So I'm going to put a minus 1 there, and we're going to factor out. Negative x divided by negative 1 is positive x. Negative 4 divided by negative 1 is 4. Okay. Now, Let's write this out in our next step and see where we're at. On top, guys, you remember how this works? 2 parentheses. One of my parentheses are the GCFs. What were my GCFs? X squared minus 1. The other parenthesis was my...
Is it x plus 4 squared?
Just x plus 4.
Yeah.
The match, you just use 1 to represent the pair. Because what's really kind of happening now is x plus 4 is in common. It's its own GCF now. So you're taking that x plus 4 that's in common, that's one of your pieces, x squared minus 1 is the other piece. Let me rewrite my denominator of x plus 4 and x minus 1. Okay. Thoughts? X plus 4 cancels with x plus 4, definitely. Yes? Okay. Other thoughts?
We can't cancel the next one, or the x minus 1 because it's x squared.
Okay. True statement. Can I cancel x minus 1 and x squared minus 1? No, because they're not identical, right? Now, there's a slight catch here.
If you, like, what's it called? Sum of squares or something like that?
It's not a sum, it's a subtraction, so it's a difference of squares.
That's what I was talking about, yeah.
Okay. Folks, x squared minus 1, we actually have one more factoring step here. And if you want to go ahead and cancel the x plus 4s, that's fine. I'm going to get them in the next step. They do cancel, not disagreeing there at all. If you went ahead and cancel them, perfect. But x squared minus 1 still factors. Do you remember if we go back to the first problem of the day? X squared minus 4.
Yeah.
We factor into x plus 2, x minus 2, right? This is the same deal, folks. So I'm going to do one more factoring step here. Whoops. Erased a little bit more than I wanted. X squared minus 1 factors into 2 parentheses. X squared minus 1, x times x. And what's the square root of 1? 1. 1 is 1 times 1, right? And if it multiplies to be a minus 1, you're going to have a plus and minus. And then what can I not forget? I haven't canceled it yet. If you haven't canceled it, you still have an x plus 4 hanging out, right? If you've canceled it, don't rewrite it. Denominator. I still have an x plus 4, and I still have my x minus 1. Can a bunch of stuff cancel?
Yeah.
Yeah. So, some of you already canceled the x plus 4. I'm getting mine out of there. Something new cancels now also, yes. X minus 1 on top cancels with x minus 1 on bottom. Any other canceling? No? What's my answer? Yeah. Officially, we could say x plus 1 over 1, but do you need to say that? No. I mean, if you really wanted to, you could say that this is x plus 1 over 1, but I'm going to tell you right now, Savas would count you wrong in a heartbeat. If everything cancels on bottom, you just have no denominator because it's over 1. Okay? Now, if everything canceled on top, you'd still have a top, right? That's when the 1 becomes necessary. Okay. It's a bunch of factoring, right? Technically factoring Algebra 1 skills, but I'm going to keep reminding you of these, right? I'm going to keep reviewing. Have I ever assumed you remember how to factor? Oh, because I know you don't. But you should be remembering by now. Okay, real quick. I can't move on without forgetting to do my...
I mean, you could.
Well, I could, but I'm going to lose half my credit if I forget my restrictions on the variable. I'm going to tell you guys, when it comes to this test, this is one of those things that I really have to, like, announce, remind. Don't forget to do the restrictions. because you can lose half your credit on a problem. Okay, how am I doing my restrictions? Anything that was ever in the denominator, right? What was my factored denominator? X plus 4 equal to 0 and x minus 1 equal to 0. I know they both canceled, but that's okay. So, solve each of those. X cannot equal what? Subtract the 4 over x cannot equal negative 4, and add the 1 over x cannot equal 1. Ooh. That's a really big comma, isn't it?
Yeah.
It's a comma, though.
The parentheses.
Let's see. Is that a little more size appropriate there?
The other one's big too.
The other one on the one was big.
Yeah.
Okay, well, I guess I'm just in a big comma mood today. I don't know. Okay. Do we have the basics with simplifying?
Yeah.
What a
Okay.
great day of notes.
Huh?
What a great day of notes.
Yeah, we're going to go a little farther. We're going to go do some multiplying. Now, here's the deal. Folks, if you know how to do this right here, if you know how to factor and cancel things, you know how to multiply fractions and you know how to divide fractions then. Because it's all based on factoring and canceling. That's what it's all based on. Okay? Now, let's look at this next section. Okay? The difference really on this bottom section is instead of having one fraction to simplify, you have two fractions to simplify.
Can't multiply together.
Okay? You don't want to multiply them together until you get to the end of the problem. Okay? Because here's the deal. We're going to factor this stuff, and what's going to happen? Some of it's going to cancel. Okay? So your first step here, it says find the simplified form of each product, state any restrictions on the variable. So we're still going to do restriction. But, okay, in general, I have to remind you, how do we multiply fractions?
Butterfly method. Keep change split.
What?
Soil.
No, what is the butterfly method?
Where you
Bro,
gonna
like
cross
this.
it?
Yeah, that's cross it. No, we're not going to cross it.
Oh, I'm like,
Okay,
Keep change
let me,
split.
we're not dividing yet.
Oh,
That'll be after Thanksgiving.
no.
Let me go back to,
I love
Okay.
Thanksgiving.
I'm going to erase this, but
Is it just straight
Multiply
across?
we're going to be doing like 2 over 3 times 1 over 5. You just multiply across.
Oh,
So 2 times 1 is 2. 3 times 5 is
15.
15.
I could've
That's
put-
our basics of multiplying fractions.
Yeah, I thought it was.
Braden's phrase is going to take us to division. That's on the back side. We'll get to that Monday after Thanksgiving. Okay? And when I hear butterfly method, you're probably thinking cross products, which is more how we solve an equation that has fractions. So, okay. Do not try and multiply this as is.
I was about to say, okay.
That would be a nightmare. Okay? We're going to factor.
Back like 4 times.
Oh my god.
We're on the. Hey, but it's the first is like difference of squares. The difference. Oh, some with difference. Oh no. Oh no, it's 5%.
Okay.
Isn't difference division or subtraction or
Difference is subtraction. Okay. X squared minus 16. Are we with her?
Would you
That's
say
what I was
you
trying to
did
say,
not
but I
hear
didn't
what you
know.
said?
X plus 4 and X minus 4.
Yeah, that'll work.
X plus 4, X minus 4. It's the difference of squares
Oh, so I was right.
because X squared is a perfect square. 16 is a perfect square. Difference because difference is our mathematical word for subtraction. And it is the subtraction of 2 squares. Okay? So, X squared minus 16. When we see 2 perfect squares being subtracted, X squared is going to break into 2 X's, X times X. We know the square root of 16 is 4. And then in order to multiply to be minus 16, you need a plus and minus. Okay, we got one set of factoring done.
It's the same thing for the bottom. Or not the same numbers, but.
Well, there's only one.
Oh, it's not an x squared. I'm blind.
What about that denominator? What about x minus 9?
Is it just x minus 9?
It was saying it was one.
Yeah. If it was x squared minus 9, I'd be right with you. Let's do what we did to the top. But it's an x to the first. If you have an x to the first, the only possible factor I can imagine would maybe be a GCF. But it's a 1x here. So we're just going to leave that as x minus 9. Okay. Second fraction. X squared plus x minus 90. Okay. Always check, mental check, do you see any GCFs?
No.
And they can factor all of them. So if you had to guess, what are you expecting we're going to be doing? Factoring into two parentheses. That would be your expectation. You're right. Now, okay, what do you know about x squared?
2x.
It's going to break into two x's, x times x. Now, before you freak out, too late, if you already have, about, now that you've come up with it, right? Multiplying to be negative 90 and adding to be 1. And this is where it might help to have a calculator by your side. Okay? If it doesn't come to you, you're probably going to kick yourself when you hear it, right?
That was a really easy one. I don't know
9
why
and 10.
I was going through my calculator like that.
Okay?
I can do it.
9 times 10 is 90, folks, yes?
And minus is
And when you subtract them, if you put a negative sign on them, if you subtract them, 10 minus 9 is a 1. Does that work?
Yes.
Now, and this is where I'm going to say, you know, like, I'm going to use Braden as an example. He had his calculator out because it didn't come to him initially.
Yeah.
And he's going through dividing things by 90. That's an option, yes?
Yeah.
And then he already pretty much admitted, yeah, that was obvious. I should have, you know. But you use the calculator to your advantage if it's just not coming to you.
I never use my
Okay. So 9 times 10 is 90. Multiplying to get negative 90, you need a positive and negative. How do you, what do we try and get? Positive 1, so,
positive 10 minus 9.
yep. Okay. Okay, denominator. X squared plus 14x plus 40. Take a guess what we're going to do. We're going to guess it's going to be x and x. Okay? X squared,
Oh, yeah.
x times x. What multiplies to be 40
10 4.
and adds to be 14. See, now you guys have 10 on the brain, don't you?
See, I didn't know the answer to that one.
Okay.
I think it's 7.
And if it multiplies to be a positive 40 and adds to be a positive 14. Plus and plus. Okay, guys. Multiplying fractions. I'm still not going to multiply these yet.
Do we cancel them now?
Yeah, we're going to cancel. Anything on top can cancel with anything on bottom. What would you like to cancel?
10 plus 10.
Okay. X plus 10 cancels with 1x plus 10 on top, cancels with 1x plus 10 on bottom. Keep going.
Oh, I keep
The 4.
x minus 9.
And x minus 9 on top cancels with
Oh.
and x minus 9 on bottom.
It's the same
Oh,
problem.
it's x plus 4.
And x plus 4 on top cancels with and x plus 4 on bottom.
That's crazy. I was already thinking it was 2 different problems.
One big fraction. Whole bunch of stuff canceled. What's my answer?
X minus 4.
Yeah. It's, you know, officially you could say it's x minus 4 over 1. But I wouldn't even do that. I would just go straight to it's x minus 4. Okay? So, yeah, it's just, folks, I always say whenever we multiply fractions and I'm trying to demonstrate for you, I always like to cross-cancel. And I think that's a technique that you guys don't do as much. I don't know, maybe it's a generation thing. I love to cross-cancel and make my numbers smaller. You want to cross-cancel. When we multiply these fractions, you're basically just writing whatever remains. Okay. Now, did it ask for restrictions? It did. How are we going to find restrictions? Your denominators equal to 0.
Oh, no.
anything that ever was or is in the denominator.
X minus 5.
So we're going to set x minus 9 equal to 0. We're going to set x plus 10 equal to 0 and x plus 4 equal to 0. Okay? What are my restrictions? X cannot equal what?
9 and 10.
Okay? Okay. I know it feels like I have a lot of examples, but every example I have it for a reason. I'm showing you something. Okay? So, we can get B done, I think. We'll find out.
4 minutes.
Yep.
Let's do this now.
Let's do it. We can do it. Now. Okay, x plus 3.
X times 3.
There's not even a GCF, folks. It's 1x to the first. Only possibility is a GCF. There's not one. Okay. 4x is a single term. It's not going to factor anything. What I will remind you, 4x is the same as saying 4 times x. Yes? Do you agree that 4x is 4 times x? So I'm just going to kind of put a multiplication dot in there, but it's 4x. X squared. It's just x squared. I am going to rewrite it, and again, I'm leaving somewhere. X squared is what times what? X times x. Okay, the one piece of factoring we have on this problem. 4x plus 12. How can that factor?
3. Nope.
GCF 4.
GCF of 4, yes. 4 and 12 both divide by 4, so put the 4 out front. What's in the parentheses? 4x divided by 4 is x. 12 divided by 4 is 3. Okay, guys. What cancels?
Oh,
X plus
X is
X.
X plus 3 on top cancels with x plus 3 on bottom.
Did you cancel an X on top?
1x on top cancels with 1x on bottom. Okay, what remains for my answer?
X over
16.
4.
X on top, 4 and 4 on bottom, or in other words,
4 squared.
x over 4 squared, which is 16.
Yeah, I'm not dumb. Try again.
Okay, the one thing I'm going to run out of time for, restrictions. What are the pieces that are going to matter?
All this numbers.
Officially, which way do you guys want to do this? The matters, so we could say 4x. When you say 4x equals 0, what's going to happen? Divide by 4, and it's going to be x cannot equal 0. And what's the other piece that matters? X plus 3. So x cannot equal 0 and negative 3. Okay, that was our stopping point for today. You need to get InSolve caught up through 4.2. Do your homework. Okay, get 4.2 done. We'll come back to these notes after Thanksgiving.
I got my 4.1 done.